Hello, good morning. I am SEEMA GARG, Associate Professor in Chemistry, SPC Government College, Ajmer. Today, lecture 2, video 123. It is on carboanions, reactive intermediate. It is for BSc Part 1, Organic Chemistry, Paper 2, Unit 1. Carboanions or carbanions. Carbanions. This is the structure of carbon anions. See here. It is a diamagnetic in nature. It is a nucleophile. It is a negative charge and act as a nucleophile. It's sp3 hybridization, and on transition states, its hybridization is sp2. It is trivalent, 8 electrons in valence shell. 6 electrons are bonded and 2 electrons are non-bonded electrons. It is sp3 hybridization. On transition state, it is sp2 hybridization. It is pyramidal in shape. It is obtained by heterolytic cleavage. Carbon anions are 3 types: primary, secondary, and tertiary. Primary carboanions, see the examples of primary. It is connected with a single carbon. Secondary carboanions are, it is connected with another carbon. Tertiary, it is connected with 3 more carbon anions. Formation of carboanions. When a group or atom departs from a carbon atom without its bonding pairs, or it is heterolysis, forms carbon anions. See here, its bonded electrons are with carbon anions. Here we can see hydrocarbon, it can form and it will give the proton. So it is a heterolysis technique. Addition of anion to double or triple bond. See here, this alkene and alkyne. When this halogens added to alkenes or alkynes, it will form carbon anions. Abstraction of a proton from or by a strong base also forms carbon anions. See here, it is aldehyde. When this proton is abstracted from alkyl group, it will form carbon anion. It is occur in aldol condensation. Here, this sodamide also form this carbon anion. Stability of carbon anion is just opposite to that of carbocation. This can be explained on the basis of inductive and resonance effect. This methyl carbanions is more stable compared to primary, then secondary, and then tertiary. See here. Effect of substituent. If electron donating groups are attached to the carbon anion, negative charge increases, stability decreases, reactivity increases. Whereas if electron withdrawing groups are attached to carbon anion, negative charge decreases, stability increases, and reactivity is decreasing. Effect of hybridization. The relative stability of the carbon anions derived from alkynes, alkanes, and alkanes can be explained on the basis of type of hybridization of the carbon carrying the negative charge. Here, it is sp hybridization of carbon, means it contains 50% of S character. Stability is increases since the electrons are closer to the nucleus and have lower energy. So it is more stable compared to this alkene. Here sp2 hybridization, S character is 33%. So it is less stable compared to alkyne. Then this alkane means methyl anion. It is sp3 hybridized carbon. Here S character is 25%. It is less stable. Resonance effect is also playing important role in the stability of carbon anion. Here, this stabilized by this carbonyl is carbon anion. So stability is also increases due to the resonance effect. Here allyl carbon anion. Allyl carbon anion is also stabilized by resonance. Benzyl carbon anion is also stabilized by its resonating structures. Relative stability order of carbon anions. Triphenyl carbon anion is more stable compared to benzyl, compared to allyl, then alkyne, then this alkene, then alkene carbon anion. Primary, secondary, and tertiary. Reactions of carbon anions. Combination with proton or electrophile, it will form alkanes. Displacement reactions, it will form this displacement reaction. This is a substitution. So it will form hydrocarbons. Next, addition to double or triple bond, it will form the polymer compound. Means easily add to this alkene group, to this carbon anion we can add to alkene group. Attack on carbonyl. This carbonyl group, carbon anion can attack and it will form the anion. Carbon anion formation is observed in following types of reaction. Reduction of halides by zinc HCl, decarboxylation of acids, nucleophilic addition reaction of alkyne, and aldol condensation. So this is all about carbon anions. In next lecture, we will see free radical reactive intermediate. Thank you very much for today's lecture.